Now here's a wee question, and that's from 2015 at paper 1, question 3. Okay, what we've got here is they're actually asking you to calculate the size of angle BD and an F. Okay, so BDF is actually, there's two angles that you're going to add together. So you're going to work out this angle, and you're going to work out this angle. You add them together, and then that will actually give you the size of the angle. Okay, so we actually use the properties that we know about in terms of with lines and triangles and circles. Okay, and it's actually not as hard as it looks. So what I'm going to start off with is, if I start off with even looking at this triangle. Now, we were made aware of, with this rule, that if you have a triangle in which one of the lengths is the diameter of the circle, it's always going to be right angled. So what we can look at is we've got a triangle here in which we've got this angle 64 degrees, and we know that this is going to be a right angle. So we can actually work out the angle EDF. So we can write angle EDF. Now, we know that there's 180 degrees in a right angle, in a triangle. So what we do is we say it's 180 minus your 90 degrees for your right angle, but also minus the 64 for the angle that's been given to you. Okay, and then you just take your calculator, but remember, this is a non-calculator paper, so in a way I'm actually cheating, right? And that is 26 degrees. Okay, so you'll have 26 degrees here. So that angle is 26 degrees. Now, we then want to actually work out the green angle. Okay, and it looks a wee bit more complex than it is. If we actually have a wee look at the first rule. The first rule says if there's a line or a tangent that intersects a circle at one point, then if you draw a radius down to that tangent to meet it, it's always going to be a right angle. So we'll see how this can help us. If we actually have a wee look at this part, goes from there to there. Okay, now this radius is actually meeting this tangent, so that must mean that this is a right angle. Okay, so from there to there is 77 degrees, and then to meet for the right angle, that must be 90 minus 77. Okay, so we can actually work out the angle, and we'll call it OBD. So we can now say angle OBD. I'll just minimize that. Now that's going to equal, it's 90 degrees, and we've already accounted for 77. So this angle must be 90 minus 77. I won't cheat and use a calculator for that. That is 13 degrees. Okay, so that's using the first rule. Now, if we have a look at the third rule, that says if you have a triangle in which two of the sides is the radius of the circle, these sides are obviously equal to each other, but that actually means that these angles are equal to each other. So if you have a wee look here, if we're saying that this is going to be 13, well, this must be 13 degrees. So what we can then do is we just add these two together, and that will give you the angle of BDF. So if we now just say angle BDF, and that's going to equal 13 degrees plus 26 degrees, and that is 39 degrees. So that's actually how you break it. So you break it into the components that you know in relation to the rules. So we've got a tangent, we've got an isosceles triangle, and we've got a right angled triangle. So that actually uses all three rules, and that's your answer.